Hello there, I'm Simber and I'm right back with your favorite train station, or at least my train station. So, in this video, I want to go over all of the computers, because I'm using quite a bit of computercraft. I have, what do I have, 4 computers here, and I have 2 over here, so I use 6 computers for this build. And I just want to go over the code for the computers. If you haven't seen my original video on this train station, I will put a annotation on the screen right now, hopefully. It'll remind me to do so. And I think you should go back and watch that first. I'll explain sort of overall how it works. Right, but I am going to start explaining the computers. So the first one that probably should be explained is this one, I think. So this computer has 5 inputs. It have this right here is I cannot remember what it's called. Let's see, Railcraft. It's a signal receiver box. Let's just get rid of that. And what that does is that if we go ahead and put on our goggles here, this is probably going to lag me out. But this box right here receives a signal. So this box right here receives signal from this one, and then the back one from the next one over, and the final one from this one. What this does is that mimics the state that this one is in. So currently this one is green, so this one is red. That makes no sense at all. But that's probably because that I'm wrong. It's the third one over here. So it's basically like right, middle, and left. Right. So this one is red because the far right over here is left. Make sense? I hope so. So what these are set to is emit redstone on aspect red. So that means, oh, now we see that train pulled up there. This one turned red. This computer right here can read the redstone inputs from the sides. So it's currently reading that this one is the redstone is true on this side and redstone is true on this side. But the last one right here is green, so the redstone is false here. So that way we on this computer know in which yard which one of these there are trains. And then this right here is Redneck Cable, I'm pretty sure it's called. And what that basically does is this one can take what the redstone aspect is on a certain side, but it can also get the bundle input. This is from back when red power was a thing. It isn't no more, but this right here uses the same way of dealing with redstone inputs, so you can just use this. So this thing right here is mimicking that thing's blinking yellow. Oh, that's because that we're currently going for a refueling run. Oh, that's why. Just getting confused there for a second. So now this thing is green, and it's emitting an redstone aspect in green, because this thing right here is green. This thing over here. This thing right here is transmitting the state of this middle one, I think. This middle one is getting it from that one. It's a bit complicated, but basically this one is equal to that one, and then just have a relay in the middle. So yeah, what this then does right here, when this, I'll just go ahead and move this right here, go back to this. When this box is green and emitting a redstone aspect, this computer over here reads that the white, as you can see right here, on the top is true. So we go, this makes this trigger no train at main station, calling one. And then it finds out which one of these are true. And that's where there's the train. And then what this does is that right here on the bottom of this, there's a wireless RedNet router or something. So it transmits to this one that says, hey, this one has one on the bottom as well. Please send me that train. And all this really does is just send the train. That's really what this computer can do. So I'm now going to show you the code for this one. So I'll just tap over to my notepad window right here. So This is the code for the first computer. It opens the rednet on the bottom, and then it has the function check trains. What the check trains function does is it just basically gets, if there's redstone on the left, it's true. Then say left to true and print out first train is here. Else set left to false. And this basically goes through for all three of the spots over in the yard. And then there's the function that send trains, and that's basically if the left is true, then send the rednet, then send a rednet message to the computer with ID 1, this computer at the ID 0, written on the top here, and then send the string left. That was the computer that basically just decided which train to send. So it just receives, oh, you want left, the train left sent, so sending this. If left is false, then it's going to go back and also going to go right. So if we just quickly tab over to the game again, that means that it's always going to send from the first yard first. If there's a train here, this one is priority 1, then 2, and then 3. So if the train is over here and that train's here, these two have to go before that one is getting selected. That's just how it works. It just doesn't choose at random, it has a priority. Right? And this was 2 functions, so this is the meat of the code. I expect that you know something about coding. It's my iPad thingy in the background. I expect you know something about computercraft if you're watching this, because I'm not going in detail, I'm just going quickly over how it works. So it goes if colors test redstone get in bundle input top colors white. What this does is there's a function called colors test, and that basically means that if that color is true, so it goes redstone get bundle input top, so it goes to the top cable as we saw before and gets the input from that. If colors.white, so we could see that it was the receiver box was of the white. That's true. Then print out no train at main station, calling one, go check trains, so then quickly going to check which train are there, then it's going to send the one that's there. And if this right here is false, like if there is a train on the main line, then the redstone signal is going to be false. So it's going to say this is false. Else if, so then we're going to test for the orange. If you go back over here, we have a wireless receiver right here. This wireless receiver is hooked up to, go through our portal here. Hopefully don't get stuck. We did get stuck. Damn it. There we go. It's hooked up to this one. I didn't know how long these rail things could transmit, so I just put a wireless transmitter on it. So this thing basically says that if there isn't a train on this, it emits a redstone signal. Over on this one right here, then the orange is going to be true, and if we go back over here, if orange is true, we go no train at lake station. Then we have this rednet.send 7 lake, and we'll go over that in just a few seconds when we're done with this. Then we go check trains, send trains, and we're going to if this thing is true, why do we, if train equals true, I have no clue where we set that. Oh, we do down here. Yeah, if train equals true, then sleep for 90. Yeah, I don't think that's necessary. That's just think we could do sleep 90. Oh, that's right. It's because up here, if there's no trains in the yard, like if both the left, back, and the right turn false, then we go train dot equals false. Then we don't wait for 90 seconds before continue. If there's a train there and we have sent one, wait for 90 seconds. Else it would, after the 10 sleep down here, it would go ahead and read the program again, and then there would still not be a train. at the lake station, and it would send another one. That would mean that all the trains were going for the lake station. Then if the last one went full, they would just get routed back. But we didn't want that, so we have a 90-second sleep. That does mean that if somebody get on the main station, then that goes 90 seconds before it sends a new one. But that's just a design choice. Right, so we have this computer with ID 7, and that is this one right here. It have a Redneck modem on the top, a wireless transmitter 7, and a wireless transmitter 4. So what does this mean? Well, this is the one that's called route trains, as you can see, ID 7. This basically have a OS pull end. When this receives a Redneck message, if the message is lake, that's the only thing that can be sent to it at the moment. This is just so it can be expanded easier. Then it's going to go right through, setting trade to lake station, left through, sleep for 10 seconds, and then set both of them to false. Then it's going to print done. And if the message isn't lake, it's going to print message is invalid. So if it says, I don't know, house, then if it's a house is invalid. Right? So what this 4 and 7 do is that this 4 over here, that is this one. That is the one that sent them to the refuel. I'll talk more about how all the routing works later, but this basically makes them go down here. And then the 7 is this one right here, so they're actually not going to refuel, they're going to get the destination of North Lake, which is going to make them go around here, and out, and up. So that's basically what this computer does. Right. I'll quickly go over the code for this one. It's fairly simple as far as I remember. Yeah, this as well waits for a witness message. It prints out the message, which we can see here is this 0, the ID, left, the message, and the distance. I just printed this out. And then what we then do is we go set the redstone. If the message is left, we go the left and set the redstone on the left true, and print first train sent. Sleep for 2, and then set it to false. We do the same with all the others if that's the one that's returns true. And else we just print message is invalid. So this computer is very simple. Then we have this one. This is our refueling. This basically just have a long countdown and then it prints out. This was more for debugging. I mean, you probably didn't want your monitor spammed like this, but it's just for sending trains, and we just have them. Yeah, that was more debugging. Now they're going around. So what this thing do? This is our refuel. This one. First of all, other than opening the render on top, we have the arcs. That's because I can do refuel and then type boot. That will make them send. It's this one right here. If arcs1 boot, then sending at boot and send trains. That's just for, again, debugging, so that I can, as soon as I start the computer, I can make them send and not having to wait the 250 seconds. Right, this function, send trains, it just prints sending trains. Then it says the redstone output on the back to true. The redstone output on the back is 4. That means that they are all going to get the destination of refuel and go down here and around. And as I say, I'm going to talk more about the routing, but basically out here, if they have refuel, they're going to go around here and back into the station. So yeah, and then next thing it's going to do is set the redstone on the left. The redstone on the left is this one, the 5, and 5 is this one right here. So the first thing it does is send the train at the station going and around here, and this does something about routing that makes it go back here as well. The next thing that it does is it goes, then it set that redstone to false. It then sends to computer number 1, sends left. sleeps 10 seconds, computer never run back, sleep 10 seconds, right, sleep 2 seconds, and set the redstone on the back to false. What this does is that, as you can see here, we got something from number 6 here. So basically we just went through all 3 of the trains and make them went to refueling. And then it ends up by turning off this number 4 here again. And then we just have the meat of the program, while through do for I equals 0, 24 do. What this does is that it's going to run this code 24 times, and just basically we have a remaining timer here, and it's going to print remaining, and then before refuel. This is just 250 minus I, which is this one, which counts up by 1 each time, but then I times 10. So yeah, it's going to be 10, 20, 30, oh, no. Right, and then we go, when this is done, we go set trains. So that was quite simple as well. The only thing, that's really the meat of the train station. That's all the computers that have something to do with like maintaining the station. The only thing we have left is this over here. We have the 2 computers down here, right here, with a Redneck modem on the bottom. But I'm just going to look at them from the front, because they don't, they might print something, I don't know. This one doesn't. This one just says button loaded. I don't take credit for the monitor. We'll look at that first, because mostly how this is done is using the bottom API by Dial 20. I understand how Lua works. I have no clue how to deal with the monitors, and this one just basically did what it needed to. And if you remember it, I'll put a annotation on the screen right now to his video on this bottom API, where you can hear how that works. But we have the train screen. Yeah, I'm just go and watch that and then come back or something. But basically, when you click a button on this, one of the red buttons, it's going to run either the function C or the function leg. And what this is going to do is print leg clicked on the computer down there. You don't see it, but it does. Then it's going to send the redness message to the computer 5 with leg, and then it's going to flash the button leg station. And the same for the C station. That's basically what this does. Then the while loop just says get event, which is this one, where it waits for something to happen on the monitor. Very, very simple code from this side. The meat is in this bottom API that I'm not going to explain because I have no clue works. But what I can talk about is the printer. This is where we get our ticket. It's the computer right beside it. What this basically does is it wraps the peripheral on the top, which is the printer. It opens the rednet on the bottom, and then it has the function C and the function leg. While it should do, wait for rednet message. If the message is C, then run the C function. The C function is just going to tm create ticket. So tm is my ticket machine that I defined up here, and then create ticket, and then what's going to print it on the ticket. And it basically does that for C, and the same for leg, and it'll print an invalid message. I think that's all the computers. So yeah, click there, this one prints. Very, very simple. I think that's basically all for the computers. I don't think I have any more computers in this. And it took 20 minutes, so that's quite a good video time. Now I just have to edit it. And then next time I might do the signals or the routing or something. As you can see, there's still plenty of more stuff to go over. So thank you so much for watching, and look forward to the next episodes where I'll be discussing all the other stuff with this. And you can download this this station from the link in the description, and if I haven't posted it here, it's in the description of the original video. I just want to say something here first. I have a problem with my receivers disappearing. So if those doesn't work on the file that I have uploaded, please comment it for me, because that's not supposed to. that's not how it's supposed to be, and I would really like to fix it then. And it's really annoying that it happens, but I'll see if I can't fix it. So, thank you guys so much for watching, and come back here next time. Goodbye.